Today I'll explain my task which is on prediction using descent algorithm. So before we proceed, let's understand what descent algorithm is. So decision tree algorithm is a type of supervised machine learning algorithm, and it is basically used for both classification and regression problem, but most of the time we use it for solving a classification problem. And decision tree is a very simple and could be easily understood by any humans because it look like a tree structure which could be interpreted. Now after that, let's dive into our code. So here I have imported the important libraries in order to perform the classification. Now after that, loading a dataset into our workspace and performing some statistical checks on it, and checking if there is any null value in it. So there is no null value, so we could proceed further. Here I have simply printed out the number of species in it. After that, printing out the number of unique variation that each attribute have. So you could see from here that petal length has 43 unique variation, which is the highest among all others. Here I have simply printed out the number of unique values for each of the attributes. Now after that, I perform exploratory data analysis on the given data set. Here I have plotted an interactive box plot using the plotly.express for each attribute, and from this you could see for each species the median and max min value for the uh, all these three species. Now after that, I have plotted an Andrew curve. So Andrew curve is basically a visualization which is used to identify the structure of a multidimensional data set. So it is like a scatter plot on which we plot data points, but in Andrew curve, each data point represent a data curve. So from this visualization, you would see that Virginica and Versicolor share some similarities because they are all showing some considerable amount of overlapping, whereas Setotsu is been very different from these two. Apart from that, we could also say that Iris data set would not be broken down into three clusters because we could see here that Versicolor and Virginica are overlapping each other, so it would be very tough to cluster them up. After that, plotting a correlation plot, which is basically a heat map, and here you could see some numbers on it. So what these numbers shows is that it shows how much is the related attributes are correlated to each other. That means if, for example, if we take a petal length and petal width, the numbers that fall in between is 0.96. That means that uh, if petal length increases, then there will be increase in petal width by 0.96 or 96%. And you could see some negative numbers as well as that means that if sepal length increases, then there will be decrease by some amount in sepal length. Now after that, I have simply plotted the 3D scatter plot of species for our given data set, and from our Andrew curve we know that Versicolor and Virginica both share some similarities, and these similarities are the ranges, the attributes, values that they share, the range that they share. You could see here that they are kind of overlapping to each other, these two, whereas Cetopso is very isolated from these two species, and the ranges that they share are as given here: 4.2 petal length 4.2 to 5, and petal width 1.25 to 1.9, and sepal length as 4.8 to 7.1 centimeter. After that, I have plotted a distribution graph. Here you could see a distribution graph for each of the attributes. Among these four, the sepal width shows a normal distribution pattern, that is increase and then decrease, whereas for the sepal length, this is an right skewed pattern, distribution pattern. Here you could see at the end of a graph, you could see a decrease in a linear fashion, whereas for the petal length and petal width, from our heat map we know that these two attributes are highly correlated to each other, so they are pretty much showing the same distribution pattern, that is an increase decrease curve pattern. distribution pattern. Now after that, I've simply plotted a species pie chart, and then a scatter plot between a sepal length and petal length. And from this plot you could also see that they are sharing some range of petal length as well as sepal length, and sepal length is shared by all these three species. After that, another scatter plot, and if I create a decision boundary here, then it would split these data point into two groups. That one that will the one will have a setotso, whereas the other one will have versicolor and virginica, and it will be very difficult to split these just by creating a decision boundary. We have to create a multiple decision boundary in between them in order to split these. So now here our decision tree model has been started. So before we create our decision tree model, we have to encode the values. So because we know that machine learning algorithm does not quite understand the language that we speak in, it does not understand the strings value. So we have to encode the string value into a numerical data. So for encoding, I have used the fit and transform. After that, I have to split the data into train and test data set. Here you could see I use a train test split method in order to split the train and into data set into train and test, giving the test size is equals to 0.2. What this means is that the train data set, the data set will be split into 80% by 20%, meaning the 80% of our observation, that is 150 observation, will be given to train data set, whereas the remaining 20% of our observation is given to our test data set, meaning the 80% of 150 observation, that is equals to 120 observation, will be given to our train data set, and the 20% of our 150 observation, which is equals to 30 observation, will be given to our test data set. And here you could see the shape of the data. Simply printing out the data set for train and test. Here you could see encoded species and name, original name. Here I am preparing the trains parameter as well as preparing the test parameter. Now training the model, then testing the model, and then checking the accuracy of our model. So for training the model, we have to create our decision tree classifier. So here I have created the decision tree classifier, then training the model by giving it value train x and train y, fitting the value into it, and after that testing the model by giving it our test cases. Then the predicted result is stored into prediction result, then using a matrix.accuracy score to compare these prediction result and with our original result, and that gives the value of 93.33% accuracy. After that, since we have done testing, training our model, we have to fit whole entire data set into our model. So for that, I have to create a target variable targets for entire data set as well as data input for our entire data set. After that, fitting the our decision tree classifier again with entire data set. After fitting the model, checking if it is predicting or working fine or not. In order to do that, I have given a block here. It is 5.9, 3.0, and 5.1, 1.8, which belongs to a respective attributes or column. So for 5.9, here you could see 5.9, 3.0, and which is 149 column, and 149 column belongs to iris virginica. Here you could see that. So the our decision tree should have predicted it rightly, the iris virginica, and here you could see the iris virginica. So our decision tree is working as we expected. Now after that, here our visualization for a decision tree classifier using importing a tree from a sklearn lib module and putting the values in it. Then here our visualization for decision tree model, and it chooses petal length as our root node and goes on splitting again until we get our leaf node, reach to our leaf node. And the And I would recommend you, if you don't know how this splitting works, so you could read articles on it. Like, the basic idea behind the splitting is a method that is called gene impurity or an entropy or information gain. So you could read those, you could read article on those on internet. And after that, I have simply printed out the textual representation for our data dictionary classifier. So yeah, this is all. Thank you for watching.